All right, we're on page 5. This problem says calculator allowed. So make sure that your calculator is ready to go. Mode doesn't matter. There's no trig involved, but you should always be in radian mode for calculus. All right, so now we're in the 2002 test. So if you want to look up the scoring guidelines, feel free to do that. The rate at which people enter an amusement park on a given day is modeled by E of t. So here's that. The rate at which people leave the same amusement park is modeled by L of t. Okay, so enter, leave. Those are both rates. They're measured in people per hour. Time is measured in hours after midnight. The functions are valid for 9 to 23 hours during which the park is open. So that's how we'll set our window when we graph this. At time t equals 9, there are no people in the park, right? So I don't have like a name for that function yet. So I'm just going to kind of highlight that and leave it there. So part A says, how many people have entered the park by 5 p.m., which is t equals 17 hours after midnight? Round your answer to the nearest whole number because we're talking about people. All right, so how do we find that? We have the rate at which people are entering, so we should just be integrating from the time the park opens. Now remember, we're doing, the functions are valid from 9 to 23, so it's not 0 to 17, it's 9 to 17. And you're putting in E of t. Now you can just write E of t dt because it's defined for you, or you can write out the function if you want to, but I'm just going to write, like I said, lazy mathematician in this case is a good mathematician, meaning laziness in the sense that you know what you're supposed to be writing and what you have to write. All right, so I need to write this. Now you can see how they put parentheses there for you, so you can type this in with parentheses. Or remember, alpha y equals will set up a fraction for you. So if you're kind of worried about parentheses or if you have something more complicated, this will save you from having to type them in. And remember, we use x instead of t. Okay, so at 15,600 over, I'm just double checking that I typed it in right. So I've got that in y1. I want to do math 9 for integrate from 9 to 17. And remember, I just stored the equation in y1, so I'm just going to do alpha trace y1 and tell it that our variable is x. So this rounds to the nearest whole person, right? So we're going to say this is 6,004 people. People entered. Okay. Now part B says the price of admission to the park is $15 until t equals 17. After 5 p.m., the price of admission to the park is $11. How many dollars are collected from admissions to the park on any given day? Round your answer to the nearest whole number. So think about this. It's going to be $15 per person. So multiplied by the number, well, I should say this, multiplied by number of people. And that's before, that's, let's say this, from what time does this open? From 9 to 5. And then we're going to add to that $11 times the number of people who entered from 5 to 23, which is when it closes. Okay, so let's set that up mathematically though. So that means that for part B, we have a cost of $15, and that's multiplied by the total number of people who enter the park from 9 to 17. And we're going to add to that $11 times, oh, sorry, not 9 to 17, excuse me, from 9 to, oh, no, yeah, sorry, it was 9 to 17. And then from 17 until the park closes, which is 23, we're going to multiply that by $11. Cost gets cheaper. All right, so I still have this stored in y1, so I'm just going to bring this back up. This plus math 9. So now I need to take it from 17 to 23, and I'm still just putting in my rate entering. Oops. I hit the wrong thing. I hit alpha graph instead of alpha trace. Here we go. Alpha trace y1, make that an x. So this is the total already added together. Round to the nearest whole number again. So this was 7276. 7276. So 7,276. Not people. I must label that people. That is a total cost. It's a total amount of revenue that they're bringing in. All right. Now, oh wait, now what did you know what I did? I made a mistake here. I forgot to put in the 15. Let me do this. Clear. Okay. Second enter can recall what you just typed. I forgot to put in any of the costs. What am I doing? Okay. So what if I do that? I don't want to retype the whole thing, but I can second insert 15 and I can second insert 11. Let's see about this. There we go. That seems like I thought that seemed low for a park. Okay. So 104,048. And this says round to the nearest whole number. So yeah, 104,048. Right? Yes. Round your answer to the nearest whole number. Okay. So that's my dollar amount. Part C. Let h of t equal the integral of, so this is the difference. You're integrating the difference and it'll end up being the number of people entering minus number of people leaving. So h of t is the number of people in the park at any given hour. Okay, so the value of h of 17 to the nearest whole number. So they gave us h of 17. Is this, find the value of h prime of 17 and explain the meaning of both h of 17 and h prime of 17. So let's start with the meaning. So h of 17, because I just did the meaning, is the number of people in the park at t equals 17. And I'm just going to say, because they told me, that's 5 p.m. Now I need to find h prime of 17. So h prime of 17, you're taking the derivative of the integral. So that's going to become, remember the t gets plugged in. That's going to equal e of 17 minus L of 17. So let's find what that number is first. We're going to round that. Let's see. Find the value. It doesn't say to round it to the nearest whole number. All right, so how do I do that? Now, I don't have L of t entered in here. So let's get that in there first. So let's go back to y equals. Keeping e of t in y1, I'm putting L of t in y2. So alpha y equals, to get a fraction, 9890 over x squared minus 38x plus 370. Now there's no integration here. Remember, we're just doing h prime of 17 is just e of 17 minus L of 17. So y1 of 17 minus minus y2 of 17. And I don't want it to be a fraction, so let me say math decimal. I guess that's the downside there. So that is negative 380.281, or I'll round it to a nearest whole just because. So what is this talking about? This is h prime. So h is the number of people in the park. So we're supposed to interpret h prime of 17. Okay, so this is the rate of change of the number of people in the park. So h prime of 17 is the rate of change of the number of people in the park. And you know what? I realized I didn't actually use the numbers, which I really should. So back here, h of 17 is the number of people in the park. So let's say there are, what was the number? 3725. 3,725 people in the park at 5 p.m. Here, because I got negative 380, the number of people in the park is decreasing, because it's negative, by 380 people per hour at t equals 7 at 5 o'clock. So this is how many people are in the park. This is how many people are leaving each hour exactly at 5 o'clock. Okay, what about part D? At what time on this interval does the model predict the number of people is at a maximum? So, all right, remember the number of people in the park is h of t. Okay, so h of t is the integral from 0 to 9. So I don't want to graph an integral. That can get kind of tricky on the calculator. So if I'm looking for a maximum, I can figure out, well, when is h prime of t? When does it have a critical number? Think first derivative test, right? So h prime of t is equal to e of t minus L of t. When is that equal to 0? All right, so let's figure out when that's equal to 0. That's also when E of t is equal to L of t. So you can do two things. On your graphing calculator, I don't really want to do y1 minus y2, although I could. I'm just looking for when are these two things equal? When do they intersect? And so I'm going to set my window from 9 to 23, and then I'm going to zoom fit, and I will see where they cross. They cross right there. So let's find that intersection point. 15 point, write the whole thing out. So this is when t is approximately 15.794815. My pen marked a spot there. That's not negative. Okay, so that's the time. And that has to be the maximum because if we're looking at h prime of t, the number of people entering is higher to begin with. And then the number of people leaving is higher in the second part. So if I were to do, let me just do this. Y1 minus y2. If this is easier to look at, let me turn off these other ones. Doop, doop, zoom fit again. Here's a better example. So h prime changes from positive to negative. That means that h increases then decreases. So the maximum number of people in the park, does this tell me to round? No. Occurs at t is about equal to 15.795. I guess I will round that. Because h prime of t changes from positive to negative and never changes to positive again. For the real AP test, write out positive and negative instead of pluses and minuses. Okay, so I know that has to be the maximum. If you want to, you could also show, the number of people in the park at the beginning is 0, so that's definitely not the maximum. The other candidate is at 23, and just think about a park here. Is the highest number of people going to be when the park closes? Absolutely not. That should be a very low number. So you can also think about that logically. All right, that finishes this problem.